So what does an assessment involve? We follow Darren Jones, an accredited energy assessor, as he visits the Tower of London, which recently had its inspection.
An energy inspection of an air conditioning system involves a visual inspection of the air conditioning installation. The inspector needs to examine the refrigeration equipment, air movement systems and associated controls. However, access to plant rooms or rooftop locations will be required. Following inspection, a report is produced which compares the size of the installed system in relation to the cooling load and suggestions for improving its energy efficiency or minimising the need for air conditioning. It also covers the current efficiency of the equipment, any faults identified during the inspection, for example a faulty control valve or damper actuator, and the adequacy of the equipment maintenance, as well as the installed controls and set points.
Air conditioning assessors will most likely be experts already working in the heating, ventilation and air conditioning sector. Air conditioning systems are broken down into two types: complex central and simple package systems. Complex central types generally consist of chilled water systems, while simple package can include split, rooftop units and variable refrigerant volume systems. Each system needs a different type of assessor. A person may become certified for both if they can demonstrate through the accreditation of prior experiential learning or APEL route that they have sufficient experience with both systems. Additionally, the assessors who are qualified to inspect simple package equipment may support their colleagues on complex central equipment.
As a self-funding charity, we've been extremely affected by the rapid rise in energy costs, along with many other organisations. We've undertaken a number of works on basic boiler plant and other equipment, but this is the first time we've had a serious look at the air conditioning plant and the significant savings that could result. It's often thought that there's little that can be done in terms of maintaining and doing energy work on historic buildings, but we found this isn't to be the case and that there are significant conservation measures that we could undertake. The report highlighted several areas of maintenance where work was being done on a periodic basis, when they actually required a more frequent attention. That the on-site engineers needed to understand exactly what it was we were trying to achieve, and we've also indulged in a bit more basic training for the engineers so that they understand how the system is set up and what we're trying to achieve and maintaining it. Getting the report prepared was the first step, but the follow-up was to get the action points implemented as a matter of urgency. Often reports are not implemented and just left on the shelf. Most of the basic items, such as insulating ductwork, setting up the correct deadbands on the AHU systems, reviewing the operating times and installing some solar reflective film to limit heat gain, were carried out within the first 3 or 4 weeks. Some of the recommendations are going to require funding, such as replacement of fans and motors, and these will be fed into the budget round for the following year. In our enthusiasm to get the recommendations of the report implemented, several of the temperature set points were altered in discussion with the staff that occupied that area, and the whole thing went beautifully. People were enthused by the idea, understood what we were trying to do. However, the second time we implemented some alterations, we neglected to mention it to the staff. As a result, there was a hail of protest from many of the staff members, almost to the point of a lynch mob forming outside my office. But once the issue was explained to the staff, we found that they've taken on board the energy savings and are prepared to accept the changes in the temperature alterations. At least it stops them fiddling with thermostats or altering any of the controls.
As a guide, an air-conditioned general office area of 2,000 square metres or more is likely to require 250 kilowatts of capacity. A general office area of 200 square metres or more is likely to require 12 kilowatts of capacity. Buildings with high levels of IT or electrical equipment may exceed these capacities at lower floor areas. If you're not sure whether your air conditioning systems reach the threshold, you must determine the installed capacity of your system by appropriate inspection, calculation and inquiries. The effective output may be given on the rating plate attached to the unit, or stated in the operating and maintenance manual. The information may also be available from the manufacturer's website or by a contractor if your system is covered by a maintenance contract.